Hello, good morning, good afternoon, good evening, depending on the time you're watching this video. I'm a geographer, so I know we have different time zones, and also you might be watching this video in the morning, the afternoon, also in the evening. So welcome to my YouTube channel, IGCSE Geography with Morris, and today I'm going to look at this topic we call river environments. But I'm going to break it into several parts because I can't deal with the whole of this topic in one single video. It's a kind of a wide topic, so I've broken it into several parts. That means that now if you've not subscribed, kindly do, so that once I upload any new video, you'll be able at least to get that video and also be able to watch that video as we move along. Now I've broken this video into several parts, and there's a part 1, there's a part 2, there's a part 3. So for the first part, I've begun with this what we call the hydrological cycle. Okay, that's the first part of this video. So by talking about that, I always have a lesson objective. Okay, what are you planning to achieve after the at the end of this lesson? Okay, now this is what you should ask yourself, like, do you know this? Okay, so by the end of this lesson, you should be able to know that to know how water moves through the hydrological cycle. Okay, you should be able to understand all that process, how water moves through the whole process of the hydrological cycle. And also you should know the characteristics of the hydrological cycle. You should also know the stores. You should also know the transfers of the hydrological cycle. That is in this single video. Okay, remember, it's wide. As I'm telling you, there's a part 1. For this part 1, you should be able to know all these things, the characteristics, the stores, and also the transfers of this hydrological cycle, like the hydrological system, the whole of it. Okay, now let's start right away, whereby we are going to talk about this hydrological cycle. Sometimes you can say a water cycle is the same thing. So hydrological cycle, water cycle is just the same thing. Okay, now let's define this. A hydrological cycle is just the endless interchange of water between the sea, atmosphere, and land. Okay, endless. I've highlighted this word endless. Why? It's not ending, it's kind of continuous. Okay, it's interchange of water, continuous interchange of that water between the sea, you see, the atmosphere, and also the land. So you see, it's kind of going up, down, up, down. That's the atmosphere to the sea to the land. It's a continuous process. So that's the simple definition of this hydrological cycle, right? So now let's look at these characteristics of this water cycle. Okay, what are these characteristics? Now, the first one, you should know that the hydrological cycle is a closed system. What do I mean by a closed system? I mean that there's no water which is added into the global budget and none is removed. Okay, when I talk about being a closed system, there's nothing in, there's nothing out. When you have this container and it's closed, so that means that everything is happening within. So there's nothing out, there's nothing in, it's closed. You understand? I've used this to elaborate. So that's what I mean by a hydrological cycle being a closed system. There's no water which is added. Okay, God does not just come to add more water. No, it's just the water that is within the whole globe, that is kind of rotating. That's what I say, endless interchange of water from the sea, land, atmosphere. Okay, that is it. Now, that is the first characteristic. Another characteristic, water is constantly recycled through the system. Okay, it's constant, so something that is happening, okay, constantly. And then the third one, we have within the hydrological cycle, there are stores, transfers, or sometimes we call the transfers as flows. Okay, so you should know that there are stores and also there are transfers in the hydrological cycle. Okay, or transfers, sometimes we say flows. Okay, so those are the three main characteristics that you should know about a hydrological cycle. But now I wanted to have this exam tip. There are no inputs and outputs in the hydrological system. Okay, we only have transfers and stores. Why? Because it's a closed system. That's why I've just explained that there is no input, there is no output. It's a closed system. Whatever we have within the hydrological cycle is the stores and the transfers, and that happens within that hydrological cycle. So no water in, no water out. I think it's clear up to that point, right? Now let's look at these stores. What are they? Okay, so the stores are as follows. Stores are those places like where water is held for a period of time. Actually, you see, when you talk about a store, it can be kept maybe for some time, for a minute, for some seconds, for a decade. You know, so it's kind of those are places where water is held for a period of time. Okay, so what are they? They include these: water in the atmosphere. That is a store. How? Because in the atmosphere we have water vapor. Okay, I think I want you to see it in that form. Like we have water vapor in the atmosphere. Actually, we also have water droplets in the atmosphere that are kind of in form of clouds. Okay, so when you talk about an atmosphere being a store on itself, like we actually mean that the atmosphere is kind of storing that water. How? There is clouds in the atmosphere. There is also water vapor in the atmosphere that actually form the clouds. So that's why the atmosphere is a store in itself. Sometimes you'll be told to explain. When you say just atmosphere, we won't understand you. So when you at least go to explain, like we have water vapor or some clouds in the atmosphere, that's where now what qualifies the atmosphere to be a store in the hydrological cycle. Another one is the surface stores. Okay, we have the surface stores such as the puddles. For those who don't know the paddles, we have such features. I think you've seen such. Then we have lakes, okay? We have rivers, and also we have reservoirs, okay? So those are the surface stores. We've talked about the atmosphere being a store. We also have those that are at the surface, okay? At the land, right? We have the paddles, lakes, rivers, and reservoirs. I think it's so clear. And then we have another one, interception. Now, when you talk about interception is whereby now you find that water is prevented from reaching the ground by the action of leaves or even stems, okay? So you see that water is being held just on the leaves or even on the stem, so it's prevented from reaching the ground. So it can be storing that water for some time. So that's why it qualifies to be a store. So interception is that store in itself. Why? Because it's kind of storing some water for some time. That's why it says store those places where water is held for a period of time. Okay, so interception is one of the store in river environments whereby we are talking about hydrological cycle. Okay, now another one is aquifers. Okay, aquifers are permeable rocks such as limestone and sandstone which can hold water. Okay, for those who don't know aquifers, maybe you look at this image. You see that? Those are aquifers. Actually, if you want to reach an aquifer, you dig a well for you to reach that water that is in the aquifer. Okay, I think it's clear there. All right, now another one, we have ice also and snow. Okay, ice, it stores water. Actually, when you talk about ice, you see it kind of holds some water for a period of time, right? Then we have also seas and oceans. Those are the stores in the hydrological cycle. So when you asked, like, what are these stores in the hydrological cycle, talk about all these things. We have those ice and snow, we have seas and oceans, we have aquifers, we have interceptions, we have surface stores, we have water in the atmosphere, or you can even say clouds, or even atmosphere in itself. That is it, guys. Those are the stores that you're talking about in the hydrological cycle. It's not that hard. It's not like rocket science. Just so easy. Geography is so easy, guys. Now, let's talk about the transfers. What are these transfers? Okay. Now, let's look at the first one. Evaporation is a transfer. How? Look at that. Changing of water into gas. Of course, that's evaporation. Changing of water into gas, called water vapor, when it's heated by the sun. Okay. Remember, it can be in the sea, it can be on the ocean, it can be on the leaves, it can be on the land. You understand? So that water is kind of heated maybe to change into water vapor. Okay, so this takes place from the surface of the sea, from water surface on land or pond, lakes, such like. So that's evaporation. Like water is heated by the sun and then changes to water vapor. That's what we call evaporation. It's a transfer itself. Why? Because it's moving. Okay, it was water, now it has changed into water vapor, and of course it will rise to the atmosphere. All right, then we have what we call transpiration. Is that transfer in the hydrological cycle? How? Plants take up liquid water from the soil by the roots. Of course, you know that process. The roots absorb water that is in the land or where they are growing. They absorb that water. it goes through the stem and then to the leaves and then into the atmosphere as water vapor. That's what we call transpiration. Is a transfer. As you can see, it's moving from the soil to the stem, then to the leaves, and then into the atmosphere as water vapor. So that's transpiration. Just as easy as that. Then we have evapotranspiration. Now, there's a difference between transpiration and evapotranspiration. Now, evapotranspiration is the combination now of that water, like from the soil, when there's that evaporation of that water from the soil, okay, and also transpiration by plants. So it's taking place like a combined loss of water from the soil through the direct evaporation and transpiration by plants. So when you talk about evaporation, evapotranspiration, talk about combined loss of that water from the soil, okay, through direct evaporation, and then by also transpiration by plants, which we've talked about up there. All right, so these are combined. The difference is these are combined loss of water from the soil through direct evaporation and transpiration, and the transpiration is just the movement of water from the roots through the stem, the leaves, into the atmosphere. Understood? Now let's look at another transfer. We have this condensation. Okay, so what is this condensation? Condensation is the change in the atmosphere when water vapor cools. Remember, evaporation has taken place. Water maybe has risen. It has gone to the atmosphere. Now it's cooling. Okay, when it cools, it becomes a liquid. That's what we call condensation. So the liquid takes the form of water droplets that appear in the atmosphere as clouds. Okay, so condensation is a transfer. Clouds are not transfers in the hydrological cycle. Clouds are like stores, but condensation is a transfer. Why? There is that change of water vapor into liquid, okay, that later now form what? Clouds. They are stored now, maybe up there. You understand? That's condensation is a transfer. Another one is precipitation. Okay, when you talk about precipitation, we don't just mean rain. Okay, we actually mean like the transfer of water in any form. It can be rain, okay, it can be hail, it can also be snow, okay, from the atmosphere to the land or sea surface. Okay, so these are any form of moisture that is being transferred. Okay, any form of moisture, can be rain, hail, or snow, okay, from the atmosphere to the land or the sea surface. Remember, we began with evaporation. It has gone up there, it has cooled by the process of condensation. After condensation, we now have formation of clouds that now leads to precipitation, which can maybe fall as rain, can fall as hail, or it can also fall as snow from the atmosphere to the land or surface, sea surface. Okay, then we have another one, overland flow. Okay, overland flow, what is it? You see now that when precipitation has fallen on the ground, you see now that it's kind of now moving. Okay, it's moving on the ground, just over the land. Okay, that's what we mean, overland flow, over the land. Precipitation has fallen on the ground and is now moving due to the effect of gravity. Remember, it can't climb a hill. It moves due to the effect of gravity, and this is what we call surface runoff. Okay, so overland flow is also what we call surface runoff. Okay, so most precipitation that hits the ground moves due to the gravity and eventually enters a stream, river, or lake. This one as surface runoff. Okay, now let's look at the seventh one, infiltration. Sometimes we can call it percolation. All right, now what is this? This is the transfer of water downwards through the soil and rock into the aquifer or groundwater store. Okay, the transfer of water downwards through the soil. We are now not talking about the overland. We are talking about just below the soil. Okay, that's why we say through the soil and rock into the aquifer. Okay, so it's kind of percolating. Okay, sinking. Let me use that one. It's kind of sinking into the soil and through the soil also into the aquifer or ground water store. That is infiltration and percolation. So it's a transfer on itself. Then we have through flow. What is this through flow? Now through flow takes place between the ground surface and the top of the groundwater store. Okay, before you reach the groundwater store, just at the top we have the ground surface, of course. Okay, so that water that is moving in between the top of that groundwater store and also the top of the soil, like the ground surface, that is what we call the movement of that, what is what we call through flow. Okay, so it actually moves as a result of gravity. You see that is kind of moving slowly through the soil until it reaches a stream of or a river, or we can even reach a lake, such like. So that's what we call through flow, just below the soil, just below the soil, not on top of the soil. On top of the soil, we're talking about surface runoff or overland flow. Okay, but through flow, we're talking about just below the soil, before you reach like at the top of the groundwater store. Okay, the movement of that water as a result of the effect of gravity. That's what we call through flow. And then we have now the ninth one, which is groundwater flow. What is this now? This happens in the rocks of the aquifer, not at the top now, like just near the bottom of the soil. No, we're now talking about in the rocks. Okay, that's the difference. This one is just at the top of the ground, groundwater store, and also the ground surface. Okay, but this one we are now talking about the rocks of the aquifer, when water is moving in those rocks of the aquifer, and is the underground actually transfer of water into rivers, lakes, and the sea. That's what we call groundwater flow. So I think I'm clear on that. All right, now this is the whole process as you can see it. Okay, and now this color, I'm kind of colorblind. I don't know whether I'll be able to identify these colors. Okay, I can see pink and green. I don't know which is green, and I can't differentiate. Okay, now look at this color here. I don't know whether this is pink, correct me if I'm wrong. So these are transfers. You see, precipitation, we have condensation, we have transpiration, we have evaporation, we have overland flow, through flow, groundwater flow, percolation, infiltration. And then we have the aquifer. Remember, aquifer, groundwater store. Okay, now these colors here, these are the transfers, and these colors are the stores. The stores we have sea, lake, atmosphere. I see snow and ice also. It's one type of a store. Then we have interception in trees and stems. Okay, so that's what we mean by the whole process of the hydrological cycle. Okay, now if you have understood this process, why can't you test yourself now? Okay, let's test ourselves, because there are some questions that are normally asked. Now let's look at some of the questions that are normally asked, and how you should be able to answer them. All right, look at that. The first question here: explain one way water is stored in the hydrological cycle. Explain one way water is stored in the hydrological cycle. What do you think? Of course, you know the stores. You know ice, you know the atmosphere, or even clouds. You know lakes, you know snow, ice. Now explain one way water is stored in the hydrological cycle. Okay, so among your answers, I expect something like this. Now this question is a 2 marks question, and now how are we supposed to answer it? You should actually get ideas from glaciers, oceans, clouds, aquifer, because these are the stores. Okay, groundwater, surface store, vegetation, ponds, those are the stores. Okay, so we award 1 mark for a point about how the water is stored, and 1 mark for further explanation. Look, when you kind of mention how water is stored, and then you explain further for mentioning that water storage, 1 mark. You go ahead to explain, you get another mark. Now look at some of these answers. Water is stored in a pond. You get 1 mark there, because you've explained, because this water being stored in where? In a pond. All right, remember, this question is not asking us to mention the stores. No, it's asking us to explain how water is stored in the hydrological cycle. So you can say water is stored in the pond. Explain now. Remember, you have 1 mark, and it's a 2 mark question, which you're supposed to mention 1 and you get 2. So you go ahead and explain, because the water doesn't drain away because of the underlying non-porous rock. So in that pond, when you explain like how is it stored there, it does not drain away because the rock there is not permeable. Okay, so you get another mark for that explanation. Look at another response that you can be answering. Water is stored in the soil. Okay, remember we have the land that it kind of stored in there because it cannot percolate through the bedrock. You can see water is kind of stored in the soil. Why? Because it's not percolating. Maybe you have the impermeable rocks there. It's not percolating, so water is stored in the soil. Okay, so look at that. Do not accept ice or water vapor. Why? Because these are just the stores, but you're not talking about how water is being stored there. Not unless you are giving your reference to a store, e.g. cloud or glacier. Now, if that's you are going to explain these, ice, water is stored in the ice, then you explain further, okay? You refer it to like how that storage is happening there, then you're going to get your mark, okay? And then it's an open question that if you give any appropriate response, we give you a mark. Understood? Now let's look at this second one. Suggest how two human factors can affect water transfers in the hydrological cycle. Now this one we are given a figure 1A in the resource booklet. To use that resource booklet to answer this question. So you are told to suggest, and the resource booklet is right here. Okay, this is what is in the resource booklet. So suggest how two human factors can affect water transfers in the hydrological cycle. Two human factors. How can it affect water transfers in the hydrological cycle? You know the transfers, of course, in the hydrological cycle. Now, what are those human factors that you know that can affect this transfer in the hydrological cycle? Now, from the source booklet, as you can see from the pictures, I can see some trees cut down, which is actually deforestation, okay? Because deforestation is the cutting down of trees. And then I can see some build-up areas, which is actually urbanization, okay? So I have two things here. I have deforestation and I have urbanization, and these are 4-mark questions. That means for each I explain, I get 2 points per explanation of a point, okay? So how is this now affecting water transfers in the hydrological cycle? How is this cutting down of trees affecting water transfers in the hydrological cycle? How is these build-up areas or urbanization kind of affecting water transfers in the hydrological cycle? Remember we talked about overland flow? You remember the surface runoff? Okay, what do you think when you look at these two scenarios, deforestation and urbanization? Okay, if you thought well, then you should be having such answers, okay? So we award actually 1 mark for identification of any idea from figure 1A, which by you say urbanization, we give you a mark. You mentioned deforestation, we give you a mark. So that's how easy it is. When you just identify that, an idea from the figure, a mark. Now another mark is coming now after now you've explained the whole of that thing. All right, now let's talk about urbanization. So you see that high levels of urbanization, remember urbanization is a kind of increased population that results into build-up areas, cities, you understand? So they'll have of kind of some surfaces that can't allow build-up areas. We have the pavements there, we have the houses that are made of concrete. You see, it's kind of not going to allow water to percolate. Understand? So when you explain in that form, you're going to get a mark. So higher levels of urbanization will increase the speed at which water is transferred into stores. Why? It increases the surface runoff. Because when water does not percolate to the ground due to these build-up areas, it's going to kind of increase that surface runoff. So it will increase the speed at which water is transferred into stores. For example, you have a river, and then we have these build-up areas, buildings made of concrete, the pavements. You see, water is not going to percolate, so that water will kind of flow faster. Okay, it's going to flow faster, maybe to a certain store, because it can't just say there. If it says there, maybe it's a pond or something. Okay, so it's kind of going to increase that speed of surface runoff. That is an effect. You get 2 points. And look at deforestation now, or removal of woodland, or cutting down of trees. That's what we call deforestation. It will increase runoff rates from slopes, increasing water transfer speeds. Deforestation, we've cut down trees. How will that affect the transfer of these water, the transfer in the hydrological cycle? It will increase runoff rates from the slopes, increasing water transfer speed. Remember, when you cut down the trees, the soil is left bare, so you find that water won't be prevented actually, so it will be flowing faster. So it will increase the surface runoffs, okay? So it will increase the water transfer speeds. You've explained that. Understand? So if you talk about this, then you're going to get your answers right. Okay, now look at another question. Identify one store in the hydrological cycle, and you're given up choices there. We have evaporation, we have infiltration, we have lake, we have a through flow. What do you think? What is the answer there? Identify one store, not transfer. I've talked about hydrological cycle. We only have two things. We have transfers and we have stores. Transfers, sometimes we call it flows, okay? So the transfers, what are they? The stores, what are they? So evaporation, is it a transfer or a store? Infiltration, is it a transfer or a store? A lake, is it a transfer or a store? Through flow, is it a transfer or a store? Okay. Then another question, identify the statement that best defines transpiration in the hydrological cycle. A statement that best defines transpiration in the hydrological cycle. What do you think transpiration is? Is it transfer of water from the atmosphere to the land? B, plants take up water from the soil and release into the atmosphere as water vapor. C, water moving through the soil as a result of gravity. D, water vapor cooling in the atmosphere to become liquid. Okay, let me give you the answers. We have them here. So the number one answer is C. Why? Because when you look at A, is evaporation. Okay, that is a transfer. When you look at B, infiltration, or sometimes we call it percolation, it is a transfer. When you look at C, it's a store because it stores water. And when you look at through flow, is a transfer. Okay, so the answer is C. And then the answer to the second one, the answer is B. Plants take up water from the soil and release it into the atmosphere as water vapor. Okay, what about the other answers? Look at that. Transfer of water from the atmosphere to the land. What is that? That is precipitation. Okay, so it's not the answer. Plants take up water from the soil and release into the atmosphere. That's now transpiration, which is the answer. Water moving through the soil as a result of gravity. What is that? That is through flow. Okay, not overland flow. The overland flow is just above the soil. Okay, over the soil, the runoff. Okay, but through flow is just through the soil. Okay, and this ground water flow is the rocks within the aquifer. Okay, then that's water, that is through flow. And then water vapor cooling in the atmosphere to become liquid, that is condensation. So the correct answer is B. Okay, so that's what I've said, that C is through flow, D is condensation. Are you seeing that? It's easy, guys. Then you go to this, the next question. Identify one transfer now in the hydrological cycle. Now from here it's easy. Is air groundwater? Groundwater is it a transfer? Infiltration, is it a transfer? Interception, is it a transfer? A lake, is it a transfer? What do you think? Of course, groundwater is a store. Infiltration is a transfer. Another name of infiltration is percolation. Okay, is a transfer. So that's the answer, B. And then C, interception, that is a store where water is being held on the leaves and also the stem. Okay, remember. And then lake is a store, water is stored in the lakes. Okay, then we have identified the statement that best define evapotranspiration. I talked about this evapotranspiration and transpiration. What's the difference? Transpiration, water being taken from the soil through the stem, then to the leaves, then into the atmosphere. What about evapotranspiration? This is now where we have a combined. Okay, now look at the choices. Loss of water from the ground, from water source and plants. Loss of water from the ground, from water stores and plants. I think a loss of water from the ground, water stores. That's what it's supposed to be. not from. Okay, so forgive me for this grammatical error here. So loss of water from the groundwater stores and plants. Is that an answer? It's an answer. Why? Because we have combined evaporation from the ground and also from the plants. When we have these combined from the ground and also from the plants, we call it evapotranspiration, but transpiration is just from the plants. Okay, then movement of water from stores underground, that's not the answer. Of course, the loss of water from the atmosphere into other stores, that is not the answer. Movement of water over the ground into other stores, that's not the answer. So that is the answer A, loss of water from the groundwater stores and plants. Okay, so you're given your mark there. And these other one, the answer was infiltration. Okay, so loss of water, the answers cannot be B, C, and D because these are they are incorrect, or they are actually transfers. Okay, then we move to another question. State 1 transfer in the hydrological circle. State 1 transfer in the hydrological circle. You sang these again and again. What do you think? A transfer. Any of these that you mention, it's an answer. Evaporation, transpiration, evapotranspiration, condensation, precipitation, overland flow, through flow, groundwater flow, stream flow, and remember you should be able to explain them. Okay, so you mention one, you get your answer. And then we have state 1 store in the hydrological circle. We've sung these again and again. So when you mention any there, you're going to get your water storage in soil. And we have aquifer, lake, lagoon, pond, puddle, reservoir, dam, glaciers, ice sheet, ice cap, ice, groundwater storage, surface water. All those are the stores. Okay, so if you mention one, but don't mention clouds, and also you mention atmosphere, it's the same. Okay, just the same, because the same thing actually. So you accept any other appropriate. The answer, the answers are open, so you can actually mention any. So now we reject underground store. Okay, we reject surface storage. Okay, we reject water, we reject groundwater flow. Those are not stores. Okay, when you talk about stores, talk about the whole of this, but don't mention underground store. No, say aquifer. Okay, instead of underground store. Surface storage, no, or surface runoff is not a store. Water is not making sense, it can be a store. Groundwater flow, no, that's a transfer, not a store. Okay, so that is it. Now let's look at another question. Explain one method of water transfer in the hydrological circle. You explain one method of water transfer. Now this just take one transfer and then you explain it. You know them: condensation, evaporation, evapotranspiration, all those things. So whichever you'll pick and then you explain, you're going to get your answers right, because you have transpiration, condensation, precipitation, runoff, which is overland flow. Okay, actually percolation, infiltration, you can explain through flow, all those things. So whatever you take and then you explain, then you're going to get your answers right. For example, evaporation is a method of water transfer. Heat, evaporation of water transfer. Okay, that is one. And then you explain now, heat energy causes water to change from water to steam. Then you see that when you pick one and then you explain it, you are going to get a point. Then runoff, you get a point. When water, you explain it, you get another point. So to be awarded the second mark, it must give the idea of water moving, because we are talking about transfers here. So if water is not moving, then we are not going to give you a mark, the second mark. You can mention it right, but wrong explanation, because you're not explain that movement of water. Okay, that is the rule there. So that's how we should answer that question. And then we move to this: identify the definition of the hydrological circle. With the definition, you said the endless interchange of water from the sea and the atmosphere also to the land. Okay, so and we say it's a closed system. So an open system, wrong. A closed system, yeah, it can be right. Now it depends the continuation. A closed system made up of only stores, wrong, because it's made of stores and transfers. So see, a closed system made up of stores and transfers, correct. Okay, so this one is correct. Why? Because it's a closed system which is made up of stores and transfers. And then the last one, D, an open system made up of only transfers. Wrong. First, open system not possible, and only transfers not possible. Okay, so that's the answer. So A, closed system, that is the answer. Then A and D are incorrect as they describe open systems. Okay, that is clear. Now you go to these. Suggest how two physical factors can affect the hydrological cycle. And we're told to study the figure 1A in the resource booklet. Okay, we suggest two physical factors. Remember, in the other place, in the other part, we talked about the human factors. We looked at deforestation and we looked at also urbanization. Remember, those are human factors. But now we talk about physical factors that affect hydrological cycle. What do you mean? Now look at that. These are factors, actually, the general factors that affect hydrological cycles. Now look at, that's what is in the resource booklet. We have the rock type. How do you think it affects the hydrological cycle? Urbanization, we've talked about that actually earlier. How do you think it affects urbanization and hydrological cycle? Sorry. Then agriculture, how does it affect hydrological cycle? Hard engineering, vegetation, atmosphere. Okay, how do they affect the hydrological cycle? Okay, so from these you just pick one and then you explain. Now look at that. Award 1 mark for identification of any idea from figure 1A, and a further mark for explanation of the reason. Okay, so when you you identify an idea, like you have an idea, like for example, rock type can impact the hydrological cycle by changing rates of surface runoff. You are given 1 mark. Don't just say rock type because it's written there. When you say rock type, you're going to get 0. But when you say rock type and you give an idea of what we expect, rock type can impact the hydrological cycle by changing the rates of surface runoff. How now? Okay, so when you maybe explain it, you can say non-porous rock will increase runoff rates. And then porous, remember we're talking about non-porous, we mean impermeable, okay? Those that cannot allow water to pass through will increase the surface runoff, okay? Or the runoff rates. And you can even go ahead and say, and porous rock will kind of reduce the surface runoff. You get that? That's rock type. You give an idea of what you expect because it will impact on the surface runoff. Now you explain how you get your second mark. Then vegetation now, because remember vegetation is also mentioned there. Vegetation, how is it going to affect that? Vegetation will affect storage in the hydrological cycle. That is an idea you've given us. It will affect the storage in the hydrological cycle. Okay, so go ahead and explain. A large number of trees will increase the amount of water intercepted and evaporated. Okay, think of having a lot of trees, and we talked about interception being one of the store. Okay, so it affects storage in the hydrological cycle because when you have so many trees, that means we have so many branches and leaves that will intercept that water that is kind of. So that's why I've given an idea that vegetation will affect storage in the hydrological cycle. It will affect the storage because when we have interception, water won't reach the ground. Why? Because it will be intercepted on the leaves and also the stems. Understand? So a large number of trees will increase the amount of water intercepted and evaporated. Remember, when it's intercepted just on the trees also, the evaporation will also take place over there. Okay? So it will affect storage in the hydrological cycle. Is it clear? Okay, another one that is mentioned there, you have atmosphere, of course. Now, how is this atmosphere kind of impacting on the hydrological cycle? Okay, so the atmosphere, global warming, that's an idea I've given. Okay, atmosphere global warming reduces ice and snow. Okay, remember there's water that is captured maybe in ice and also the snow. So when you have this global warming, it will kind of make the water to evaporate. That means it is going to reduce, okay? It's going to reduce the storage of that water in the ice and snow. Remember, ice and snow are part of the storage in the hydrological cycle. So when you explain that, when you mention that, that's an idea of given us. Now explain. It raises ocean storage. You see that? So when the light ice and snow melts, what do you expect? It will flow into the storage, maybe to the ocean, to the rivers, you know. It will flow, okay, to the oceans, and so it will increase the storage in the ocean. And also precipitation, actually. You understand? Because it has evaporated and then it's going to fall as rain. You see that? That's what I'm trying to say, okay? So this question needs you at least to think in that manner. Like we've given there, it's mentioned there. You give us an idea and then you explain further. You give your second mark. So accept any other appropriate response that is right, okay? So guys, let's look at another one. Explain two transfers in the hydrological cycle shown. So we have a figure there in the resource booklet, and right there we have there. Okay, transpiration, precipitation, evaporation. So that's the whole process of hydrological cycle. So here we have transfers, we have also the stores. So we are told you explain two transfers from this resource booklet. Don't go outside, just from this resource booklet. What are the transfers that you can see there? You pick one and then you explain, you get an answer. We can pick any there. We can pick transpiration, we can pick precipitation, we can pick evaporation, we can pick condensation, we can pick, don't pick ocean because that's a store. Don't pick a lake because there's a store. Okay? Percolation is a transfer. Groundwater flow, there's a transfer. So we can pick any and then explain. Now let's pick this and then explain. Evaporation is a transfer. This occurs when water changes from a liquid into water. You see that? You get. So evaporation is a transfer. You mention that, a mark, and then you explain another mark. Condensation is a transfer. You've identified one mark, explain another mark. Precipitation is a transfer, a mark, you explain another mark. Snow melt is also a transfer. Okay, remember it starts snow melting. Okay, remember snow is a store, but now when it's melting, it's kind of a transfer. Okay, so occurs when water changes from a solid to a liquid as temperature increases. So by that you'll have explained this. So you pick one mark. You explain. It's quite different from the previous question that we've seen. You give an idea because, of course, whatever you are going to pick is mentioned in the resource booklet. So when you pick that, you give an idea of that, you get a mark, and then further explanation, you get another mark. Understood? Now, guys, that is actually the end of this video. So I encourage you to go watch out the part 2, because I've said that this topic is wide, river environments is wide. I've just dealt with the hydrological cycle. So make sure you watch the second part, whereby we'll be going to discuss the drainage basin, and then we look at some of the questions that are asked and how to answer those questions. So that is it, guys. Please don't forget to subscribe so that once I upload any video, you can be able to be notified when you hit that bell button. Even you can actually get access of that video easily once I upload. That is it, guys. Have a nice time.